Okay, so we'll provide you with some summary for the translation rules. And you can use this table as your reference when you are working on your homework as well as in your projects. So in this table, the first column denotes the ER diagram. We can create the right-hand side denotes the relations we can get after we do the translation. So given a entity, right? This entity, the rectangle. This entity has a bunch of attributes A1 to AN. A1 is a key. And based on the rules we showed before, we can translate this entity into a relation. E, it covers A1 to AN as attributes. A1 is a key, it is highlighted with underline, right? So the translation of the entity is very simple. Then this one will show the translation of this relationship is R1. R1 is a many-to-many relationship. So the E1 is entity, E2 is another entity. A1 is the key of E1, and B1 is the key of the E2. C1 to CK are the attributes of the R1 relationship. Then we can do the translation of this ER diagram into of the relationship R1 into R1. We cover this A1, B1 as the key attributes inside it by borrowing from this annotation, right? And we can also have a C1 to CK as the descriptive attributes of the relationship. So this is a many-to-many case. And for the relationships with one-to-many or one-to-one, these are constraints, then the translation will be slightly different, right? This is we show here an example here. We have E2 and E1. We have one arrow pointing to E1, right? We know that given an entity in this E2, we can always find one single entity in the E1 to form a relation in the R1, right? Therefore, if we treat this R1 as a regular case, we can do the translation as shown here. R1, right, covers A1, B1 as the key attributes, C1 to CK as its attributes, right? We find that this B1 is a key of E2, right? And we also know that given an entity in E2, we can always find one single entity in E1 that will form a relation in this R1, right? And based on our previous description, we mentioned that we can combine this R1 and E2 together, right, into a new relation. And we can just ignore this R1 and add all the remaining attributes into E2 instead, right? And we also remove this redundant, this B1. We only store the B1 only once, right? So here we have the E2. This is a new relation as shown here, right? And if this one is a one-to-one relationship, and then we can either combine the left-hand side or the right-hand side, depending on which one you prefer. Either side will work for the translation. And we show the translation rules for this relationship. If it is many-to-many, it's very simple. We have E1, E2, and R1, right? If it is one-to-many, the translation will be slightly different, right? We have E1 as a relation, right? And we combine R1 with E2 and form a new relation as E2 shown here, right? If it is many-to-one, the translation will be combination on the left-hand side. We have E1 combined with R1, right? It will be larger relation, and we have E2 as shown here. How about this one-to-one? We can either treat it as a one-to-many or many-to-one, depending on which one you prefer. So for the working state, we mentioned, right? If we do the translation of the diagram like this, we have E1, it is a regular entity. We translated it according to the entities we showed before, right? E1 as a relation, A1, AN as attributes, A1 is a key. And for the E2 as this relation between them, we propose to combine them together, right? Combine this relation with E2 together to define the E2 as this relation. We also have to borrow this A1, this attribute, as one side inside this E2 relation, right, as a key attribute. Therefore, the translation will be like this: E2 equals to A1 is a key, right? A1, B1 together we define the key for the new relation, as well as the remaining attributes inside this E2, right? This is the translation for the working states. We also have the translation for the subclass we mentioned in the slides. We have two different approaches. The first approach is called the ER approach, right? For the ER approach, we do the translation of diagram like this into three relations: E1, S1, and S2. For the subclass S1 and S2, we have to borrow this A1 key attributes inside this relation as keys as well, right? We have E1 is a regular entity relation after the translation, and we have S1. We add this A1 as a key attribute. We have B1 to BM as the remaining attributes, and we have S2. We add the A1 as a key attribute, C1 to CK as the remaining attributes. This is called ER approach. We have another approach, it's called OO approach, right? In this approach, we define two relations, S1 and S2. In both of them, we have to add this attribute for E1 inside them, right? Therefore, we have S1 equals to A1 to AN. They are all added here. A1 is a key. We also have this B1 to BM as the remaining attributes, right? We have S2, it adds this A1 to AN as its attributes. We have C1 to CK as the remaining attributes. A1 is a key for both of these two relations, right? Okay, so this is the translation rules summarization we can provide for you. It generally covers all the cases for the translation of ER diagrams into relations. You can check these rules very carefully, and I hope you can follow what I mentioned in the summarization, right? And you can also use these tables as your reference when you do the homework for the translation of ER diagrams into relations. Okay, so that's it for this section. And if you have any question, you can let me know by either sending me emails or talk with me during the office hours. And in the following two sections before the midterm, we'll talk about this relational algebra as well as relational design. So the relational algebra focuses to introduce some operators we can operate to do the queries on these relations. And the relational design focuses on further polish this relation into better ones. We'll provide them one by one in the following two sections before the midterm. Okay, that's it for this section. Thanks for your attention, and we will go to the next section very soon.